who started CoCalc. And in this video, I'm going to show you how to copy very efficiently files from one compute server running anywhere to another compute server running somewhere else. For example, suppose you have maybe 2 or 3 gigabytes of data sitting on one compute server that you created who knows where, and you want to copy it over efficiently to another compute server. And let's do it. So what I will do is create 2 compute servers in this project. So I'll call the first one server 1, and I will make it on Google Cloud, and it will be, let's just say for fun, in Europe, in Italy. Okay, and let's just start it going, leave everything else as the defaults. Okay, so now this one's starting up. Now I'll make another compute server, which I will call server 2. And I will make that one in, how about Japan? Okay, and let's start this one up. Okay, so over the next minute or two, these 2 servers will start running. In the meantime, I'm going to create a new terminal, which I'll call copy.term. And I will split it horizontally. And on the left, I'm going to have server 1. And on the right, I will have server 2. And my goal is going to be to use rsync to copy files from server 1 to server 2. This won't just work initially. And the reason is because I don't have any SSH keys set up at all between these 2 machines. So I need to set up SSH keys in order to do the copy. And so I'll do that as follows. In a third terminal, I'll just call it ssh.term. I'm going to generate a new SSH key. What is the name of that elliptic curve? ssh-keygent 25519. There it is. For some reason, I'm not remembering. Okay. So what I've typed in here is ssh-keygent TED 25519. And that will generate an SSH key pair that is sitting on my in my CoCalc project. So I'm going to overwrite the existing one I happen to have had there. I'll use an empty passphrase, though you may want to use a non-empty passphrase for better security. Now let's look at the public part of my SSH key. There it is. And now I'm going to do is copy this key. I'm going to go to the settings page, scroll down to SSH keys, and then add this key in the project for copying demo. So I put the key in and then click add key. Once I add this SSH key, then it will be available to any compute server that I start in this project, by which I mean that I can use this SSH key to connect to any such compute server. And so we just started these 2 compute servers, and within 20 or 30 seconds, we'll build SSH to them as explained here. So let's just try that out. Right, so if we want to SSH to one of these compute servers, we have to use its IP address. So I can do SSH, and it's actually user at, and then the IP address. And that allowed me to connect via SSH from my home-based project to the compute server. By the way, you could just take the same SSH key pair or make your own SSH key pair, put it on your laptop, and then directly SSH to your compute server that way, if you ever need to do that. Okay, back to the question of copying files between our compute servers. First, let's test that now that we have this SSH key set up, we should be able to SSH from one compute server to the other. So let's see if that works. So this is SSHing from compute server 121 to compute server 122. Let's look at the host name, and it worked. So we're able to SSH from server-1 to server-2. I think we can also say SSH server-2 rather than having to write compute. Actually, you really have to say compute server 122. These titles are extremely arbitrary, and so they can't actually be used as domain names. You can put absolutely anything here, and so it's not necessarily a valid domain name. So each compute server has a name, which is just compute-server- the ID number of the compute server. Okay, so now let's put some files on compute server 121 in the Scratch directory. So I'm going to do this. I'll do git clone. I'm going to grab the source code of CoCalc itself, which is right here. And I'm just going to copy it into this Scratch directory. Just a quick, easy way of giving me about 500 megabytes of random stuff. It's not too random because I wrote a lot of it, but just a whole bunch of things. And just for fun, I'll make a tarball of this as well, so we have a little bit more data. And then we're going to copy it over to this other compute server. And just remember, geographically, this machine is in Italy, and this other one is in Japan. So when we do the copy, it's going across the globe. There is a cost associated with this. It will be probably about 10 cents. But it's basically on the order of 10 cents per gigabyte of data that we copy. And we'll be copying on the order of 1 gigabyte of data. The cost depends a lot on where your compute servers are located. If they're in the same data center, it could be a lot cheaper. And the cost is mainly for the data going out from the compute server. If the compute server is on-prem or on HyperStack, then data going out is free, and the incoming data is also very inexpensive. But transferring data between two Google Cloud compute servers that are on the opposite side of the globe, that's going to be about 10 to 15 cents per gigabyte. Okay, so we now have our CoCalc directory, or source code, which involves 4,900 files and 584 megabytes of data. And just for fun, I'm going to tar it up. So just showing you that the file system is very fast. This data is all local to the compute server in Italy. And now we're going to rsync the data from Italy to Japan. For the Japan compute server, there's nothing in the Scratch directory. So I type rsync axvH, then scratch / and then compute server 122 : scratch. So this is just a standard rsync command between any two Linux servers when you have SSH keys set up. So I'm not doing anything at all special to CoCalc. So I hit enter, and the moment I do that, files should start getting copied once things are authenticated, and we should start seeing them showing up over here. Let's see. Oh, I forgot a dash. rsync - axvH scratch. I just forgot the little dash command line option. Okay, now we should see files start showing up here. And there they are. So it's little by little, but this is basically the most efficient and robust way to transfer data from one server to another. And a really cool property of using rsync is that if we interrupt it along the way and then do it again, it will pick up where it left off. In particular, it's really it's like a remote synchronization mechanism. That's why it's called rsync. So the idea is that if you had files, a huge directory of files on one machine, and you're editing them, and then you like the other machine to see an exact copy of everything that you've done on the first machine, you can do an initial rsync, do a bunch of editing on the first machine, and then do another rsync, and it will just copy over the differences. Even if you have a huge file, it'll like copy over just the pieces of the file that have changed. So it's very clever and efficient. Okay, let's see how we're doing. I'm in the way. It looks like it's about half the way done. Now let's see how it's doing on the CoCalc directory, which it created for some reason. Okay, now it's copying the directory, as you can see. And it finished the tarball. It's not so ridiculously clever that it knows that the tarball it just copied has the same contents as this directory. So it doesn't deduplicate at the block level. That would be very, very difficult. So rsync definitely does not do that, but it's still pretty clever. So as you can see, we've copied 797 megabytes of data so far. And here we go. And again, the command we're running is rsync-axv capital H, the first directory with a slash after it, the name of the target computer, colon, and then the directory we want it to end up with a slash after it. And you can read, just ask Google and it will tell you everything you could possibly want to know about rsync, or you can use a large language model. For example, if I copy this and click on AI, I can say GPT-4, please explain what this rsync command does. And it will tell you. Oh, and by the way, it's done. And here's the explanation of what it does. Synchronizes files. -A is archive mode, which ensures that permissions, links, etc. are transferred. X means that you don't accidentally cross file system boundaries. V means it's verbose, so you can see the files as they're being transferred. And H involves hard links. So most of these are actually irrelevant for the purposes of what we're doing here. You could probably just use -V. Okay. All right, so we now have our files. And I want to illustrate also just that, let's say I just change one file over here. So open scratch CoCalc readme. I'm going to change just a little bit of one of these files. So change this for the demo on the computer in Italy. And then I'm going to run rsync again. And instead of it copying a gigabyte of data, it's going to copy just that one little piece of that one file that changed. And so it should be a lot more efficient. And then over here, let's check that it actually modified readme.md. And look, indeed it did. It says change this for the demo. So as you can see, and notice here it only copied this one file over, and there's a huge speed up as a result. Okay, so there you are. That's how you can very efficiently copy files using rsync between any two compute servers that are in the same project. What I just described would be a little bit more complicated if the compute servers are in different projects. If they're in different projects, you have to go to the other project and also add this SSH key to the other project so that the compute server in the other project knows about it. Moreover, the name compute server-121, say, or compute server-ID, that's not going to work between two different projects because after all, the ID numbers start at 1 in each project individually. And so there could easily be another compute server with the same name over there. However, the IP address will work. So instead of using the name, just directly use the IP address of the compute server, and that will let you copy between projects if you need to do so. Okay, so that concludes this video. Thanks a lot, and contact us if you have any questions.